All right, I think we're live. Let's see if anyone has joined. Good morning, good morning. Hey, BZ. Tim is here. Ooh, I'm tired.
Hey Jacob,
Hi. How was your Saturday? How's your Saturday going, BZ? Oh, I can't hear you if you're talking.
Oh, it's the push to talk. How do I switch this?
Yep.
Like I was just like talking with myself. What? Okay.
No, I hear you.
yes, it was very good because I was busy in a problem.
Nice. It's great to hear. Hey, Bruce.
Good morning, everyone.
Good morning, good morning.
Now, yeah, okay, now it works.
Okay.
Cool. Well, how was your Saturday, Jacob?
It was good. I woke up about 30 minutes ago realizing I missed the Twitter space, so that's terrible. I feel so bad about that. But yeah, I mean, I guess we're here and ready to go with Emerald Academy, so
Yep.
we're probably gonna start in like a few minutes just to let people sort of roll in. And then I think after today we'll have wrapped up chapter 1 and 2, so it's actually pretty cool because after chapter 2, people should know about like structs and dictionaries and arrays, so a lot of like the fundamental stuff will be sort of done. Morning to you, nicely iced. Hey there, Kelcoin. Good to see you, of course. Hello, hello. BZ, do you know if SWT is coming today?
I don't, but yeah, I just texted with her like an hour ago. I don't know, but it's Saturday, so usually people.
I didn't even realize you knew SWT in real life.
I don't.
Oh, you don't?
No, she's like one of the most engaged community members at the Basic Beast, and like now a friend, right? So.
Oh, that's fantastic.
So she lives in the U.S. just like you.
Yeah, I know. She lives in I think she's actually in the same time zone as me, so it's probably early for her.
Oh, that's.
All right. Yeah, so we can get started. For all of you that came, thank you very much. And yeah, I hope this session is helpful for all of you. So really quick, I see that Brainchild, so I know that you're here, and you had just asked me in the Quest Submissions channel, do I have to redefine pre and post conditions in the main contract? So it's actually, it won't show you an error, like right off the bat, but there actually is an error hidden inside account 4 that if you use the function, it'll be totally useless. So that's one thing to look out for, if that's a helpful hint. Okay. So here we are. We are live on this lovely Saturday morning. And today we're going to be wrapping up, chapter 1 and 2. So just to give a brief little overview of what we went over in the previous workshop. So I'm also seeing, yay, SWT's here. Hi, SWT. And also, hey, Cubic Ray. So in the previous workshop, we went over how to make a contract. So let's just call it like test. And then inside of this contract, we had, some very basic stuff. Like we had like a public let, greeting or something. This was like a string. And then we went over how to modify this data, right? So, in our init function, we just said like self.greeting equals like hello idiot, I think we did. And then we also had a function, to change it, right? So public function like change greeting. And this just took in like a new greeting, for example. I think I was doing this with numbers, but it's the same thing with strings. And we would say like, self.greeting equals new greeting, right? So something like this was what we sort of went over in the last example. So I have to refresh just because it's being weird. But yeah, so we can go ahead and deploy this, and we deployed the contract, and then we simply ran some scripts and transactions to change this. So one example is in a script we could say import test from account 1, and then we simply want to return like a string, and we can return test.greeting, right? And so if we execute this, then it just says hello idiot, right? So that's an example of reading our value from the blockchain. And then one more before we get into some new material is what if we wanted to call this function to actually change our greeting, right? So inside of a transaction, because we want to change the data on the blockchain, we can go ahead and say import test from account 1. And inside the execute phase, we can just say, test. Let's actually refresh so we get like the syntax highlighting, dot change greeting. And the new greeting, we can pass in a new greeting here. So let's go ahead and pass that in through the transaction. So a new greeting, and this is a string. And then it allows us to sort of type in this little box here. So we can say like, instead of hello idiot, we want it to be like, hello, wonderful people. If we have to remember to put it in quotes because it's a string, right? So if we run this, then it says, oh, okay, so it's just being glitchy. So if there's anything we also learned during the last session, is that the playground is extremely buggy, but we're working with what we can. So hello, wonderful people, and hopefully if we click send, then it will go through. And if we then go to a script and read this again, it says hello, wonderful people, right? So that's sort of what the point of of going over basically the point of what the last workshop was, to show that we can have some data on the blockchain and then modify it, right? So in this workshop, we're going to be going over some more complex data types. So Brainchild asks, how come your playground has a dark mode? So mine has a dark mode. You can see it's not like actually a dark mode because it just only makes this dark. But this is a Google Chrome extension. I think if you look up like Flow Playground, this is like a Chrome extension you can add. But it's kind of it's like old and broken, so it's not like the best. But yeah. Okay. So so in this example, we have like a string, right? And a string, if we go to like a script, for example, a string is just like some text. So examples of this are like hello, or like hello idiot, or something like that, where there's quotes around your string. But if we look at like an int, for example, an int is a number. So an int is something like 5 or 3 or that, or negative with something, or 0. So that's what an int is. But there's more complex data types that we can actually use to help us write our Cadence programs. One of these is called an array. And so an array is, you can think of it almost like, something that's in brackets, right? So an array has multiple items inside of it. So one example is if we have like 1, 5, -2, 3, and 0. And so this array is almost like a list of numbers inside of it. And so we would call this a list of numbers. So the way you would write that in Cadence is you do this little like list notation, and then you put the type that's inside these brackets. And so in this case, because it's a list of integers, right, because integers are numbers, we would say the type is a list of int, just like that. And so let's actually go into our contract here. Let's get rid of this kind of stuff because we're gonna sort of go over this later. but let's do a new public var list of numbers. And we're going to make it a list of ints, right? And so what we can do is in our init function, it's saying, it's missing initialization. We can say self.list of numbers equals empty brackets. So whereas in, the string case, we had like a string and then we initialize it to hello idiot. In this case, we're just going to initialize it to an empty bracket. So this is totally fine. But what we could also do just to help us test is we can put some initial data in here. So why don't we actually just put like 4, 5, 1, 100, right? And let's also put like a negative number. So like -10, right? Awesome. So if we go ahead and, deploy this contract, let's go ahead and deploy it. Boom, it's deployed. And so let's actually read our list of numbers from this contract. So if we go to the script and we return, let's go ahead and return a list of integers, just like that. We can return test.list of numbers. And let's see what happens when we run this. Of course, it's being buggy. Boom. So let's execute. And then look, so wow, we get a lot of stuff here, right? And this isn't like, this doesn't look that nice, but it's it's just like the playground formatting our answer into like a weird thingy. But you can see that if we look really closely, I don't know how well you can see it, but it says the type is an array and the value has all these other values inside of it. So it has 4, it has 5, it has 1, it has 100, and it has -10, right? Which is exactly what we put inside of here. So this is cool and all, but it might be more helpful if we access specific numbers inside of here so that we can get the info that we want. And so let's actually do that together. So right now, let's go back to our script. Let me make sure this is full screen. Okay, let's go back to our script. And instead of returning a list of numbers like that, let's actually store this instead of a variable. So let's say let numbers. The type is going to be an int like that. And this equals test.list of numbers, just like that. And so you might be asking, well, what does like this syntax mean? Like, what does it mean if we have like colon or what is it called? Yeah, colon, and then like like the type right here. All this is saying is that numbers is a list of integers and that it equals test.list of numbers. But this is the same thing as doing this, right? You don't need to put the type there, but it's helpful for us to like figure out what the type of this thing is. Okay. So then how do we access specific things inside of our array here? Well, let's go ahead and return the first thing, the very first thing. So let's say return numbers at 0. And so you might be wondering, like, what is, 0? Well, 0 is an index. Right here, this is saying we want the very first element. So it's a little confusing because in computer science, you would think that like the first thing is just 1, but you actually always start from 0. So 0 means the first thing, 1 means the second thing, 2 means the third thing, and so on, right, into infinity. So let's go ahead and say we want numbers at the first index, and this is going to be an integer. So, we can sort of guess that the first thing here is going to be 4 because that's the very first thing inside of our array. So if we execute this, let's clear and then execute. It says the type is 4, the type is int, and the value is 4, just like we wanted. And so what if we wanted like the fourth element? So let's put numbers at 3, and this should be fine. It's just glitchy. So if we execute this one, then it says type int value 100, and this makes sense because 3 is 0, 1, 2, 3. So it's 100 right there. Awesome. So that is a brief introduction to arrays. Now, what if we wanted to modify this array, right? What if we wanted to say, okay, we want to add elements to this array? Well, let's actually go ahead and make a function for that. So add to list. Let's put in a number here to add. So let's go ahead, number like that. And then we can say inside this add self.list of numbers dot append and then the number right here. So what this is saying is take the list of numbers and then dot append. So if you've programmed before, you've probably seen this function, but if not, it's totally okay as well. What dot append means is take whatever is in these little parentheses here and put it at the very end. So it's the same thing as me saying, okay, I want to put 5. That's appending something to the array, just like that. So if we redeploy this contract, let's go ahead into a transaction because we're going to be modifying what's in this list, right? So let's go ahead into this transaction and let us say test.add to list and the number that we're going to add. So let's go ahead and pass in the number up here, which is going to be an integer. And we can pass in some sort of number. So let's pass in like negative 13, right? My lucky number is 13. And of course it's being weird. Hold on. Okay, so 13. Cool. So there were no errors, so it should be fine. So if we go into our script now and we execute this, oh yeah, so we want to, it's saying it's still getting the thing at 3, right? But let's picture where this is going to be. So this is 0, 1, 2, 3, 4, and then we just added something at 5. So let's go ahead and say numbers at 5. If we execute this, it's pausing for some reason. That's weird. Execute. Yeah. So now it says numbers at 5 equals 13, which is the number we just added. So woohoo, we just added something to our array, and now, now we can read from it. Now you might be wondering, well, what happens if you put something here that like doesn't even exist? Well, we can try it. Let's put something in there that doesn't even make any sense. Execute this, and it says array index out of bounds. So it says the size is 6. So remember, because the size is 6, the maximum number we can put in here is 5. And so that's just an example of like adding an element to the array. Cool. Now, actually, I'm going to go back to this chapter because I think, if I remember correctly, that I actually added like a good list of functions that we can also use. So yeah, so inside the course, I say helpful array functions that I use all the time. So append is one of them that puts an element at the end of the array, and also contains. So contains is really helpful because contains allows us to know if something is in the array or not. So if we wanted to, we could return a bool here. And we could say return numbers dot contains, let's say 13, right? So hopefully this should work. So this is saying if numbers dot contains 13, this is going to return true or false. So we can execute this and it says true because it does contain 13, right? We just added that to our array. But what if we wanted to say dot add, I don't know, 54, right? That we know that doesn't exist because we never added that. So if we execute this, it'll say false because it's not in the array. Now, one other thing that I think is really helpful is dot length and also dot remove. So dot remove allows us to remove an element at a specific index. So if we look at our array here, let's say we wanted to remove 5, right? This is at index 1. So we can go ahead in our transaction, and actually, we could even make a new function for this called remove from list, and we can take in an index. And the index is the spot at which we want to remove it from. So we can say self.list of numbers dot remove index. I believe that's the syntax, or is it? Yeah, so it should be this. Oh, it should be at. Okay. So hopefully if we refresh the playground now, yeah. So we're going to say self.list of numbers dot remove at this specific index, and then it'll remove that element, right? So if we redeploy this contract, let's go ahead and remove 5. So let us say inside this transaction, test dot remove from list. It's going to take in an index, and let's just say 1. And then we don't even have to, like, let's just not pass in any parameters. So if we execute this now, it's boom, it's done. And so now we can go ahead and return our list of numbers, which is just a list of integers. And if we execute, you'll see that there's no 5 anymore. 5 is totally gone. And we can even, if we want to, we can log numbers.length. And if we execute this again, you'll see that it logs 4, right? And initially there were 5, but we just removed 5. We just removed the number 5. So now there's only 4 elements in this array. So cool. That is sort of a short overview of arrays. Does anyone have any quick questions about that? The next thing we're going to do is probably much more interesting, which is dictionaries. All right. Cool. Yeah, so if you have any questions about that, just feel free to let me know. It's totally okay to ask any questions you have. All right. So let's go ahead and start with another thing, which is dictionaries. So let us say, well, actually, first of all, before we even get into dictionaries, let's go over what they are. So we went over what arrays are, and arrays are basically a list of stuff, which is cool. But what's probably even cooler, and just as a hint, I use dictionaries like way more than arrays. So while arrays are very helpful, you'll probably be using dictionaries almost all the time in your Cadence programs because they're really helpful. So arrays are lists of stuff, but what dictionaries are is they map stuff. And what do I mean by mapping? Well, a dictionary could take something like Jacob, right, which is my first name, and map it to my last name, Tucker, like that. And so what this will do is if you say, hey, hi dictionary, I want to know what the value is at Jacob, it will say, oh, the value at Jacob is Tucker. And so this is an example of a dictionary that maps a first name to a last name, just like that. And similarly, we could put in like other cool stuff here, right? So if we wanted to put in like food, because I'm hungry, we can map food to like burger, right? So we can really map anything we want. The important point is that inside of dictionaries, it maps a specific type to another type. So like string to string, or we can map like, if we wanted to, like in a new dictionary, we can map like lucky, like, we can map like Jacob's lucky number, which is a string, and we can map that to like 13, for example. And so the way you actually, type a dictionary, so with arrays, the type is like brackets and then int. With a dictionary, you use this syntax with these little curly braces, and you put in the key type, so like string, and then the value type, which is int. So in this case, because a dictionary is mapping a string to an integer, we put string maps to an int, just like that. So let's go ahead and actually start testing this in our contract again. So let's say we were going to make a new variable called public variable, like mapping, or what should we put here? Actually, what's a cool thing to map? I'm trying to think what I used in the example. Well, let's say like school ratings, right? So let's go ahead and map a string to an integer. So we're gonna map, we're gonna basically rate schools in the United States, because those are the schools that I know. And so the way that you initialize this is you say self.school ratings, and you do like this little syntax equals the empty curly braces. So this is totally fine. This will initialize school ratings to it like an empty dictionary. But what we can do, just like with arrays, is we can put in some sample data here. So let's say Northwestern, that's the school that I go to, and we'll rank this as number 1, right? Because it's the best of all time. We can put like Harvard, and we can map them to -10 because they're trash. We can also map, what's another one? We can map Yale to -15,000 because they're also trash. So you get the point, right? So we basically initialize this initialize this dictionary to map a string, which is, a name of a school, to an integer, which is the rating. And the way that you map it is you put this little colon, right? So Northwestern maps to 1, Harvard maps to -10, Yale maps to -14,000, right? So let's go ahead and deploy this contract. Boom. And then inside of our script, we can just return test. Today I learned that Harvard is true. So we can return a dictionary that maps strings to ints, and it says test.school ratings, just like that. Cool. Let's go ahead and refresh because playground is lovely. And we can execute this. Suck in our true. I'm building up a team here. Nice. So you can see that what we returned here is a dictionary. The value is key, or the value is saying, the type is a string, Harvard, and Harvard maps to -10. It's very hard to read this, but you sort of get used to it. Northwestern, which is a key, maps to 1, and stuff like that. So how does this actually, get useful? I'm so happy to learn this, Jacob. So I love you too, Skyo. That's awesome. So inside of the script, we could just say let ratings, and the type is going to be a string to integer. And the reason we're doing this is because we want to access a certain, we want to get a certain key. So you want to say, hey, what does Northwestern map to, right? And then hopefully it should give us 1. So we're going to say ratings has the type string to int, and this equals test.school ratings. And then, you know, we're going to be returning an integer, by the way, because we're going to be using a mapping. Then we're going to return ratings. Oops. Return ratings at, oh God, I can't spell, at Northwestern, right? And let's go ahead and refresh the page. Okay, oops. So like that. And then look, so we get this error. So this right here, this error is the second half of this sort of chapter. So why we're getting this error here. You'll notice that this error says expected int got int question mark. So for now, let's just completely ignore this and don't worry about why I put this here. But let's just first use this so that we can actually get the value at this point, right? So let's go ahead and execute. And it says the value is 1, right? So I just wanted to prove to you that if we put in Northwestern here, it'll give us 1. Whereas if we put in Harvard, let's see the official rating of Harvard. Let's execute garbage, right? So that's sort of the point here. And I also list some helpful functions that you can use with dictionaries. So .insert is a really helpful one. Actually, .insert's not really that helpful, but .remove is very helpful. Keys is also helpful to get the keys, values. So let's actually do some of these right now. Let's log. We can log ratings.keys, and let's also log ratings.values. Ratings.keys is going to print an array of all the keys. So ratings.keys will print Northwestern, Harvard, and Yale, whereas ratings.values will print all the values. So 1, -10, and -14,000. So if we execute this script, you'll see it prints an array of all the keys, then an array of all the values, and then it's returning, you know, whatever is here. So one more thing that's actually pretty cool is if we want to make a function, public function remove ratings, or like remove rating, we can take in a school, which is a string, and you know we can make this little function here, and we can say self.school ratings.remove, and let's see what the syntax is here, because even the Cadence legend forgets. So we put in a key, so the key, and then we put in like the school, right? So that's going to remove whatever this school is from this mapping. So if we go ahead and deploy this contract inside of our transaction, we can refresh the page and just say test.remove rating, and the school, let's just remove Yale, just like this. And if we send this transaction, so it's being weird. So if we send this transaction, it will go through, and then inside of our script, let's go ahead and return. So let's return just ratings as a whole, which maps a string to an int. And we will see that if we execute this, boom, Yale is no longer inside of our dictionary, right? It is completely gone. And notice that it also removed the value that was associated with Yale. So now it's totally gone. So we removed from our dictionary, which is awesome. And if we wanted to add to our dictionary, you can, of course, use this insert. But one thing that's actually much more helpful is you can do something else. So I'll just demo it like in here if we wanted to add. Actually, no, I'll do it in the contract. So if we wanted to make a function to add, so let's add a rating. And we're going to take in the school and then the rating, which is an int. We can actually say self.school ratings. And you can totally do .insert. So let me refresh this so that it'll actually come up with like the auto completion. So we can actually do .insert, and it'll take in the key, which is the school, and the value, which is rating. And you can this will totally work. So this will add in the school and then put the rating that's associated with it. But a much more clean solution, in my opinion, is just to say self.school ratings, and then you put this little bracket here. So this is like the key, and you can put in school equals the rating. So I like to use this syntax much more because this makes more sense to me. So you're saying, you know, self.school ratings, you put the key in, which is the school, and then the rating. So if we redeploy this, we can actually go to our transaction, and we can refresh and just say test.add rating. The school, let's put in like Brown, and the rating will be like 3, right? Because they're pretty cool. And so we can go ahead and send this. It will go through, and then inside of our script, if we execute, now Brown is back in, right? So now they're in. And you'll notice Yale is also back in, but that's just because I like redeployed the contract. All right, so that is dictionaries for us. And then one of the last things we'll talk about today is optionals. So optionals are pretty cool in Cadence. And so that's I'm excited to show you what this is. So I'm going to go ahead and delete some of this stuff that we can pay really close attention to optionals. All right. It looks like the only thing people learned today were my opinions about schools, so that's great. All right, onward. To infinity and beyond. Oh, so future question, can you store anything in arrays like resources? Yes. So for we will totally go over resources inside of arrays and dictionaries, but you absolutely can. Yes. And I'll show you how to do that next week during our next workshop. Cool. Good question, Bruce. So let's go over optionals. So what the heck is an optional? So put simply, actually, you know, we can even go to the course for this. So an optional type in Cadence is represented with a question mark. It means it is either the type it's saying or nil. So what the heck did I say? So let's actually copy this into the playground because this will be helpful for us. So an optional type in Cadence is represented with a question mark. It means it is either the type it's saying or nil. So let's go ahead and make a variable here called name. And we're going to say that this has the type string question mark, right? And this equals Jacob. So normally, right, like if we wanted to have a name here, we would just say, okay, the string is Jacob, right? And then we could just log name here like that. Now why is it giving me this? Yeah, so it's being the playground again. So if we execute this, it'll just print Jacob, right? But if we put this little string question mark here, just like that, you'll notice that if we execute, it's the same exact thing. It also prints Jacob. And that's because this is totally fine, right? An optional type in Cadence is represented with a question mark. So this is saying that name, so name is an optional type. And it's saying that name is either a string, so it's either a string or it's nil. So what we can also do is instead of putting Jacob, right, let's put nil. And you'll notice that nil is not a string, but it is nil. And so that's allowed in this optional type. So we can go ahead and execute this and it's nil, right? So boom, just like that. So the reason that we're going over this is because sometimes in Cadence, you will have a optional type and you'll need to quote unquote unwrap it into its actual type. So which would be string. So I'll show you an example of this. So let's say that we wanted main to return a string, right? We're going to say, you know what? Our script is going to return a string. Now, the problem here is that if we return name, look at what it's giving us. It's saying, wait a minute, mismatched types. We wanted a string, but we got a string question mark. And it's right? It's asking for, you know, it's saying, okay, we're going to return a string, but we're giving it a string question mark. So how do you actually unwrap this? So let's go ahead and put Jacob back here again. And the way to do this is you put this little exclamation mark. And the exclamation mark says, okay, we're going to take whatever is in this little variable. And if it's not nil, we're going to return like a non-optional type. So what I mean by this, let's make it even more clear. Let's say let unwrapped name. This is going to be a string. And this equals name exclamation mark. And then we can return unwrapped name, right? So if we go ahead and execute this, now it's totally happy. And it returns Jacob. Because we took the optional, we unwrapped it into a basic string, and then return the unwrapped name. So then you may be asking, well, what happens if this is nil then, right? What is this unwrap going to actually do? And the answer is that it's going to panic. It's going to have a problem. So it says unexpectedly found nil while forcing an optional value. And it's right, because this little exclamation mark says, hey, if this thing that we're unwrapping is actually nil, then abort the program. It's a problem. We don't want to do this. It's really bad. So that's what that means. So if we go back to our example with school ratings, let's go to our script again. And let us say, let rating be an integer. And this is going to equal test.school ratings. I don't know why it's being weird. Maybe I have to refresh. So test.school ratings. at Northwestern. Just like that. And you'll notice it says, hey, mismatched types. We expected an int, got an int question mark. So let's actually make this int as well. And so the reason for that is because, look, this is supposed to be an int question mark because a dictionary, when you access its key, it always returns an optional type. And so we have to, let's just get rid of this error here really quick. So you'll see that, you know, when we return rating here, it's not happy because we're returning an optional instead of an actual int. And so we have to unwrap it with the exclamation mark in order to make it happy. And now if we execute, it says 1. So it's totally fine now. So I just wanted to show you that because it's really important that if you ever get this error, like, oh, mismatched types, we expected an int, but we got an int question mark. All that means you have to unwrap it with this little exclamation mark here, and that's all good. And I just want to just say one thing. The reason for this is because what happens if we tried to put in something stupid? So let's put in like a weird thing, right? The thing is that before we actually run this program, it doesn't know that this doesn't exist. So to us, it looks like this is fine, but it's actually not fine because this doesn't exist. And so then when we go ahead and we unwrap it again, look what's going to happen. And we're going to execute it, and it's going to say, unexpectedly found no while forcing an optional value. And that's because this behind the scenes is actually nil, right? So that's why it's giving us an optional, because this value this key does not exist in school ratings. So this will return nil, which is fine because it's an optional type. But then when we go to unwrap it on this line, it's going to give us a problem and say, you can't, you know, we found nil while forcing an optional value. So does anyone have questions about that? Because that can get a little confusing. But I hope that makes sense. And I think I just explained everything that I meant to. Yeah. Okay. So is everyone okay with that? Hopefully I didn't bore out. Hopefully I didn't bore all of you. Okay, yeah, totally. Okay, awesome. Great. Yeah, and if you're ever extremely bored, just let me know. We can have like a 2-minute debrief where we just go crazy for a second. Sometimes it's important just to stretch and take a break. Actually, you know what? Why don't we do that right now? All right, we're loading up Flappy Bird. All right, so we're gonna play 3 Flappy Bird games, and if I don't get to 10, then I lose. Okay, but let's see how much I get. We're playing, and I already lost. What the heck? How am I this? Okay, wait, hold on. I'm trying again. Wait, wait 1 sec. Okay, so we're only doing this because we're taking a quick break before we get into Structs. All right, so the goal is to get to 10. Oh my god. No. Oh, I'm so sad. That's so depressing. Okay, one more. And then we'll go back. I'm so nervous right now. No. Oh my god. Okay, one more. I promise, last one. I'm so annoyed. Okay, wait. This is entertainment right here, by the way. This is top quality content. Oh my god, I'm freaking out. My hands are shaking. Oh my god. Yes! We got to 10. Let's go. Let's go. I knew I had it in me. All right, nice. All right. So we just did Flappy Bird, and we're back and better than ever. Look at Bam. Look at you. Okay. I see you with that. Yeah, that's a great way to use dictionaries, right? And then maybe all of you can try Flappy Bird and we can map all of that into one big dictionary. Okay. Nice. Okay, so we're back. All right, so we just went over, let's see what we went over so far. So we went over arrays, we went over dictionaries, we went over optionals, and we went over unwrapping optionals. Just like that. Okay. So that's what we went over right now. The very last thing we're going to talk about is something called structs. So what are structs? Well, I'm very glad you asked. I'm talking to myself. It's kind of embarrassing. But a struct is basically like I would argue that a struct is probably like the second most complex data type. So a struct is basically like a container of data. So a struct is a container of data. Exactly, Brent. Yes, you got it, because that was my 4th attempt. I like that. Look at you. Good stuff. So you know what? If I've learned anything, it's that Flappy Bird teaches us everything we need to know about cadence. In all my YouTube videos, I also play Flappy Bird because I think it's fun. Okay. Good job, everyone, with the analogies there. Okay, so a struct is a container of data. So it's basically like, we can also say that a struct like contains many different fields inside of it. So what does that mean? Well, public struct, let's just say, let's just call it a container. We can just call it, well, you can call this anything you want. We can call this Jacob. We can call this Bob. We can call this BZ. We can anything you want, but let's just call it container. Actually, you know what? No, let's call it profile. I want to do a profile example. Okay, so inside of the profile, we can have a bunch of different fields that we want. So let's go ahead and say public let name. And this is going to be a string. Let's say public let I don't know. I think I actually did an example in here, right? So first name, last name, birthday, and account. Okay, so let's go ahead and say first name, last name is a string. Public let, what is this? Birthday? Yeah, so birthday is a string. Let's say public let lucky number is an int, and then public let address is, let's say, an address. So I'm listing all these, and let's just get rid of like last name, for example. But the reason I'm doing all these different ones is because I want to show you that you can put any different type you want in here. And we can even put like a dictionary if you want. So public let like stuff. We can put like a string to string mapping. We can put literally anything we want in here. But just like in the contract, where if we define a variable, we have to initialize it. It's the same thing with a struct. So we have to initialize all of this data to equal something. So let's go ahead and pass in some data that we can use to initialize the first name. So let's say first name is going to be a string. And I like to put little underscores next to my init fields because it helps me differentiate between what this is and what this is. So let's say first name. Let's also get rid of birth. Let's just make things simple. So let's say lucky number is an int. Address is going to be an address. Throw underscore here, and then let's say stuff is going to be a string to string mapping, just like that. So in here we can say self.firstName equals underscore first name. Self.lucky number equals lucky number. Self.address equals address. And then self.stuff. Actually, I'm not gonna use this in our example. What we can do is we can literally just say self.stuff equals an empty dictionary, right? So I'm just going to use this to show you that you can put stuff in here. But yeah. So Rainchild says, can we use function or resource? So inside of a struct, so most of you won't know this yet, but because you don't know what resources are, but no, you cannot use resources in structs. You can use functions though, which I'll get into in a second. So anyway, yeah, so inside of our struct, we're saying that when we create this struct, we're going to pass in a first name, we're going to pass in a lucky number, we're going to pass in an address, and we're going to initialize all of those, and then we're just going to say stuff equals like an empty whatever, right? So we don't like, we're not going to really care about this, but it's just there to show you that you can put stuff in there. All right. So that's all cool. So let's go ahead and deploy this contract. And now we've defined like a little container of data. So inside of our script, let's go ahead and say, let a profile equals, let's also refresh, just make sure it's like going to work. So test.profile, and look, it even has auto completion. And then we have to pass some stuff in here to actually initialize our profile. So the things it wants are a first name, a lucky number, and an address. So let's take these things, go to our script, and just copy them into here. And then, obviously we don't put the types here, we put the actual values. So let's say the first name we want it to be Jacob, lucky number 13, and the address, let's just say 0x1, just a dummy address, right? Cool. And then let's log the profile, just like that. Refresh. Oh no. Oh my god, that was scary. Okay, we're back. So if we go ahead and execute this, then look at what it logged. It says it logs a test.profile with a lucky number of 13, a first name of Jacob, a stuff of empty, and an address of 1. So you can see that test.profile is really just a container of other data, right? It's a way for us to put some data inside of almost like a container so that we can represent some common information. And that's sort of the point that I wanted to get across, is that the main reason for structs is if you have some common set of data that you want to be grouped together. So in this case, you know, my profile has my first name, it has my lucky number, it has my address and my stuff. You know, these are all stuff that are somewhat related to a profile. And so that's why we linked it into one. That's why we put it inside one, you know, little container called profile here. So that's cool and all. But, you know, how do we actually, like, you know, do some cool stuff with this, right? So we want to do some cool stuff. So let's actually look at what I did in here. Yeah, okay, so I see what I did. So what I did in my example was I stored a list of profiles. So let's go ahead and say public var. Let's do a you know, something called profiles. And in here, we're going to do a list of profiles. So we're going to map an address to a profile. And you'll notice that profile is an actual type. Look at that, right? So it's an actual type that we can use, even though it's not like, you know, built into Cadence. And then we can say self.profiles equals an empty dictionary like that. So we probably want to have a way to add to this dictionary. So let's go ahead and say public function add profile, right? And let's pass in some data. So let's pass in a first name, which is a string. Let's pass in a lucky number, which is an int. And let's pass in an address, which is an address. And in here, we're going to do what we did in the script. We're going to make a new profile, right? So let's go ahead and let's make a new profile. So let profile equals a new profile. So we open this up. The first name is first name. So remember, this is talking about this is the label. So this is the label. And then we actually pass in the value, which is coming from this parameter. Then we say lucky number is going to be lucky number. And address is going to be address. Just like that. And then we can say self.profiles. And remember I showed you, you can either do .insert or you can use this syntax. At the address, so we're going to map the address to the actual profile. So at address equals the profile we just made. Like that, right? And so if we go ahead and refresh this thing, good. So it's all good to go. So I'm going to pause here really quickly. So does anyone have any questions about what this is doing? Because at this point, you should have some understanding of what this is doing. And if you don't, that's totally fine. But does anyone have any questions about that? Okay. So it sounds like everyone is okay. Okay, cool. So, yeah, so we're adding a profile, right? Okay, cool. So inside of our transaction, let us go to our transaction and let us add a new profile. So test.add, should be there. Test, that's weird. Try it again. Test.add, okay, I guess not. Add profile. And we're going to pass in some stuff. So we're going to pass in, actually, I really wish it was here. That's strange. Why is it? Oh, did we not redeploy this? Oh, that's why. Okay, yeah, we didn't redeploy it. So if we go back in here and say test.add profile, you'll see it opens up all this up for us. So let's pass in Jacob. Let's pass in the lucky number. And let's pass in just a dummy address. And then after it's done, let's just log like done, right? Just that we know that the transaction went through. So let's go ahead and send this. And it says done. Boom. So it's done. And now we can go to our script and let's read the profiles. So let us return a address to test.profile mapping. And let's return test.profiles. Now, one quick thing before I run this, it's really important to note that I did not say address to profile here. I said address to test.profile. So note that in this contract, I just put profile. And that's because this contract knows what the profile type is, right? Because it's already defined in the same contract. But in the script, it has no idea what you're referring to, right? Because you can have tons of different contracts that all have a profile struct in them. So this is saying we're referring to the test.profile that's defined in this contract, right? So that's important. And now let's execute this. And you can see it returns a long list of stuff that's really hard to read. But basically, all it's saying is that it contains the profile we just added. And if we wanted to, let's actually, instead of returning a mapping, let's just return one test.profile. And the way we can do that is we can say return test.profiles. And because it's a dictionary, let's actually get the value at the certain key that we want. So the key is an address. So let's say 0x1. And if you remember, that's what I passed in as the address here, 0x01. And then in the contract, it mapped 0x01 that we got in from here to the profile associated with that address, right? So inside of our script, and look what it's saying, mismatch types, expected test.profile got test.profile question mark, and we know how to solve that now. We unwrap it with the exclamation mark, right? So refresh, boom. So if we execute now, look what it gave us. So it gave us a long list, but basically it says the first name is Jacob, the lucky number is 13, the address is 1, and the stuff is just an empty because we didn't do anything with that. So boom, that is how we define structs, add them maybe to a dictionary, and do all that fun stuff. Now, the very last thing that I'm going to show you before we wrap up for today is that inside of structs, you can also add functions. So for example, we can have public function change first name, take in a new name, which is a string, and then go in here and say self.firstName equals new name, right? And let's just make this var because let is a constant. So we can actually define structs in here, which is really cool. Let's go ahead and redeploy, and I'll show you this inside of a script. So inside of the script, we can actually say let profile equals, and let's just copy some code here so that we're not like writing all this out again. It's like this. So let's just say Jacob 13 and then OX01. And this is a test.profile. And then, so we store it in this profile, right? And so what we can do is we can log profile.firstName. Okay? And also just a note that if you want to, right, we have a profile. If you want to just get the first name, you can do profile.firstName or profile.luckynumber, right? So we're going to say, let's get the first name, and this should be Jacob. And then we're going to do profile dot, let me actually refresh again so that we get the highlighting. So profile dot change first name to be, let's just say, who's in here. So I'll pick a random person. So let's say Willie Blue, right? Hi, Willie Blue, by the way. And then, so we change the first name, and then we can log profile dot first name again, right? Cool. So let's see what happens here. So when we execute, great. So I think I have to refresh maybe. Yes. Okay. So look what it did. So it logged Jacob and then it logged Willie Blue, right? So perfect. So we called the function and it changed the profile. Now, of course, this is all being done in a script. So, we just make a new profile, we get the first name, and then, right here, this returns Willie Blue. And then, this is all good. But what we could do if we wanted to was like, for example, we have this profile here, and then we have this add. We can even add a function to change a certain name at a certain profile. So this is the last thing we're going to do. So public function change like name, for example, we can take in the address so that we know which profile we're talking about, right? So let's say it maps like 1 to a profile. We can get in an address here. So this should be an address. And then we can get the new name, which should be a string. And what we can do is say so we can say self.profiles at the address dot like I wonder what would happen if I refresh this dot change dot change first name, the new name. So just like that. And I'm actually thinking, I don't know if this will work because I think we might have to do references, which we'll get into next week. But let me actually try and see if this works. So the sort of the point that you can try and see is that we're calling this function change name that takes in an address so that we can actually get the value from this dictionary. And then we were calling change first name on it. I don't think this is going to work though, but we can actually try and test this together. So if you go to a transaction, we can add a profile like this. So let's go ahead and add the profile, and then we can make another transaction. So let's go ahead and get this transaction and copy paste it. And instead of saying test.add profile, we can say test.change, or let's refresh again. The test.change name. And the address is going to be 1 because that's what we use to make it. So that's how we're going to identify it, right? So OXO1. And the new name we can put in as like Willy Blue, right? So hopefully this will, I don't know if this will change the name, but let's go ahead and see. So let's log test.profiles at OXO1.firstName. That should be fine. Oh, and we have to unwrap this, right? So if we execute this, it should say Jacob. Now, if we go ahead and change the name, I don't know if this will work, but let's see. Oh, it actually did work. Okay, nice. So it actually did work. So in our transaction, we changed the name to Willy Blue, right? So all that did is it called change name with the OXO1 address. It got the profile right here, and then called change first name on it, which changes the first name. And then in the script, we say we're just logging the first name of that profile, right? And you can see that it worked. So it changed the name officially. So boom, that's it. So if you understand all of that, then you're officially done with chapter 1 and 2. So that's all there is for chapter 1 and 2. And for next week, it's going to be a little less, but it's going to be probably harder material. So next week, you're going to learn chapter 3. So you're going to do all of chapter 3. And then like the first, like, I think 2 days of chapter 4. So yeah. Hopefully that was helpful for everybody. And that's all I have for you today. Nice. Can we use structs inside a resource? Yes, of course. You can even use structs inside structs. So let's go ahead and let me show you an example. So if let's just get rid of all this stuff. We can get rid of all this. Let me show you. So let's just throw like a first name, for example. Right, so just make it much simpler. So we can actually make another struct called like second struct. And what we can do is in here, we can say public var second equals second struct. And we can just say self.second equals second struct. Just like that. So you can store structs in resources and structs in structs. An infinite list of structs. Yep, structception. Should we give Flappy Bird one more go before we wrap it up? See if we can beat our high score of 11. Oh, wow. Well, I'm on a roll. Jinxed it. I totally jinxed it. Welp. Totally failed. GG. GG, well played. Maybe during one of these office hours, we'll load up a Minecraft world. Should we do that? Should we play group Minecraft? So that when we get bored, we can build a house. Oh, trust me, BZ. After a 60+ minute game, I'm typing things a lot more mean than that. Trust me. I am going all flame war after 60 minutes. Is anyone else starving? I'm so hungry. Horizon Forbidden West. Ooh. What is that? This looks cool. I like that. Look at that like graphics there. Oh, a PS5 game. Nice. Yeah, I've never heard of this before. Looks cool though. All right, everybody. I don't want to keep you for too long, and that's the end of the workshop. So, yeah, hopefully you all found this helpful. And like I said, I'm sorry for missing yesterday. Yeah, I completely messed up my time zones again, which is pretty common for me, but I hate that. So anyway, yeah, next week I'll see you live again on Wednesday. But in the meantime, have a fantastic weekend. Love all of you. And yeah, do some fun stuff this weekend. Relax and take care of yourself. Chocolate chip pancakes, those are my favorite, Brainchild. You know that. Yep, yep, exactly. Bye, everybody. Thank you, SWT, for coming. Thanks, BZ. Thanks, Willy Blue. Thanks, Cubic Ray. Bye, bye, bye. Bye, Calcoin. Bye, Brainchild. Bye, bye.